Onwards now with our next guest presenter. He joins us from the 2026 Cherry Blossoms Conference in Cambridge today. He is Murat Çakmak of Zaya, and he's going to be talking about one of his products today, Microservice Store. And today he's talking more specifically autonomous compliance, operationalizing EU CRA and UK PSTI via embedded microservices. If you're watching live, please put any questions for Murat in Zoom chat, and we'll put those to him soon. Murat, the floor is yours, my friend.
Okay, then. Hi, everyone. Thank you, Christopher. So, yeah, we are from Zytec as part of the IoT Security Foundation. I mean, we are a member, and Microservice Store is likely our new project, which comes with compliance automation frameworks, which I'm going to talk about today. But before start, maybe we can talk about the open questions about compliance. At the moment, the basic approach is like manual reporting by the vendors. So we leave all the responsibility to vendors. So they need to invest maybe all this compliance stuff, and they need to maybe have teams or mechanisms to manually report to CRA. And if something is manual, we cannot fully trust the process because there are human in the middle. And the second problem is monolithic firmwares, because at the moment, the foundational problem of the IoT domain is dominated by the monolithic approaches. Because when we have an image, we are mixing everything. And in case of any vulnerability in an IoT product, we cannot even address like where it is. So our reporting going to be like a binary, like I have a vulnerability, but no idea where it is. And the other problem is who gonna fix the vulnerabilities. Let's say we have many software components and even some of them open source coming from third party. And if we address this problem, who gonna fix for it? And are we gonna wait for voluntary efforts from the third party? And okay, the compliance forces vendors to produce higher quality with SBOMs, vulnerability reporting, but still, because of the existing approaches, in case of any vulnerability in an IoT device, still vulnerability can break the whole system, which can be really catastrophic for maybe critical infrastructures. So these questions still open for the compliance, and that's where we are trying to provide a proactive automation for the compliance. So herein, we believe that there are three layers in the security, because compliance is kind of like interface between vendor and the legislation bodies. But actually, it should be more than this, because before this parts, we should guarantee like, okay, there is a secure system, layer by layer. So for this, let's go one by one for each layer. First is supply chain security. So like protecting the entire fleet and operations, like protecting the supply chain protection against supply chain attacks or in-field security life cycles. And maybe we can even include EU CRI as part of this item, like automating SBOM and vulnerability reporting instead of manual reporting. And the second layer could be device protection. So protecting the embedded device proactively. Because as I mentioned, in the monolithic approaches, in case of any vulnerability or crash, the whole device crash, maybe even entire fleet dies. Here in the device protection, proactively, we should contain the any vulnerability. And maybe we can keep alive the rest of the system for the real-time or critical infrastructures. And then, yes, if we're gonna provide a vulnerability, it should be maybe model level reporting. And of course, like handling all the security requirements, like secure boots, secure update, anti-rollback protection. It's all device protection. And herein, we are trying to provide more granularity for the security we call microservice protection. So in our architecture, I'm gonna give more detail later. So we are providing a new technology called microservice, which is like splitting IoT device into submodules and protecting each of them separately, like they are virtual environments. So, okay, we have device level protection requirements like secure boot, secure lifecycle, but we are expanding these requirements to each software module individually. Of course, they are isolated and vulnerability reporting gonna be per microservice. So I came from top to bottom, but now let's go from bottom to top as a solution. So this is like traditional approach for us. We are having many modern, maybe operating systems approaches. I would say Zephyr, very popular nowadays. So if you are developing a traditional solution in the left, it looks really nice for the PowerPoint slides. Like you can see different layers, modules, each of them, like there's nice interaction between them. This is in theory, and it looks nice on PowerPoint slides. But in reality, when you have an image, when you build it, so you are just mixing everything into single image. So there's no isolation. Any module can break anything, even your kernel, even third party can break your whole device. And all design tightly coupled, which reduces your flexibility during the design. So actually, I'm telling this because if you're gonna build something for CRA, maybe before CRA reporting or something, we should solve some foundational problems of the IoT scope. Now here at the bottom, we are coming with some new approaches. We call microservices embedded. We can also call like embedded microservice, and they are designed for IoT devices, even for MMU-less microcontrollers. So the idea is like, instead of mixing all software into single image, let's separate them into software modules. And each module is an independent executable. You can even use different programming languages, C, Python, Rust, whatever. You can even use different tool chains, different projects, even developed by different teams. And they are individually deployable. So you don't need to update the whole firmware if you need any updates. And the most critical part is plug and play here. It's a plug and play technology. And in case of any vulnerability, we just quarantine the vulnerable module and the rest of system always alive. Actually, this approach, similar to Cherry, so Cherry offers this one, compartmentalization, but with our technology, you can have this technology with any architecture, even legacy smallest microcontrollers like ARM Cortex-M0. So as I mentioned, each microservice is an independent virtual environment. We expand device requirements to each microservice, like they are isolated, independent lifecycle, individually secure boot, upgrades, and part of attestation token. You may worry like, wow, it's a nice, cool technology, but what about like, oh, how are we gonna migrate? Because from our experiences, like Zephyr forces you to some new structures, new build system, something. But containers are totally platform agnostic. There is no dependency like hardware driver. It just started main platform agnostic, just start implementing your pure codes on it. And there is no performance overheads. So once we solve this foundational problem at the bottom, in the microservice store, you can manage any fleet's product with digital twins. So just create a logical copy of your product and just decide what microservice to use, like maybe crypto or file system or communication protocol, and just give explicit access to images, and that's all. Field devices connect here. They align themselves, so all lifecycle is automated. And in case of any vulnerability, you can monitor your vulnerability from your device twins. So because this is critical, okay, you can have vulnerability, you can report to CRA, but you have to be monitoring vulnerability in your site as well. So you should have full control. And digital twins provides full control for you. And so microservices, like we are, how to say, converting even open source libraries into microservices, plug and play microservices. For example, maybe you are using a third party, let's say Embed TLS. In case of any vulnerability in Embed TLS, this third party library can break your system. But we are converting them. So we are running them as isolated and plug and play microservices. And in case of any vulnerability, we just quarantine this third-party library, rest of system alive. We report you. We also report to third-party library vendor. And other thing, a good thing about microservices, AI is getting strong also in embedded systems, but AI, how are we going to trust AI generated code? So here, instead of creating whole firmware, you can generate any microservice by AI. And in case of any vulnerability in AI generated codes, it reports back and we report back to CRA again. Actually, I mentioned this third party as microservices. So you can monitor your systems like what products are failing before reporting to EU CRI. And then this part, now finally we come to EU CRI part. So if you authorize us to report your product to report the EU CRI, we implemented all the infrastructure for you. And in case of any vulnerability, instead of saying like, okay, there is a vulnerability to CRI, we are combining SBOM and vulnerability together and providing single report. So we can even tell EU CRI like, okay, this product is failing, but also this module is failing. And this approach is kind of open. You can even open your product status to public. And we are trying to build a centralized trust. Let's say, okay, there are microservices around. They can be even open source by the popular open source libraries, and there can be vulnerabilities. So in the same portal, you can see like products status. You can even see the services like microservice statuses. Because our point is like, instead of manual reporting to EU CRI, we are trying to build something else. Let's say this is the traditional approach at the moment. I wouldn't say traditional because it is not that old, but at the moment, the existing approach is, okay, just interface between vendor and EU CRI and voluntarily reporting. Actually, I wouldn't say voluntarily, but yeah, vendor, we leave it vendor. But herein, we are trying to build a centralized security hub. Let's say there are different product vendors. Maybe they are having different products. And maybe these products using the same microservice. And in case of any vulnerability reporting, even a single device, it doesn't have to be a whole fleet. The device reports to microservice store, and microservice store reports the product, but not only the product. It also reports all products using the same microservice, even they don't show any vulnerability. And we also notify them like, okay, guys, you are using this microservice, but this is vulnerable. Just be careful, you need fixes. So, and we are reporting all the products, all the different vendors at the same time, like a centralized security hub. I'm done for my presentation at the moment. So I'm happy to answer if you guys have any questions.
Thank you very much indeed, Murat Çakmak. I will just put myself back on camera. 1 second. I will get into the Q&A section of today's broadcast.